Okay, welcome all. My name is Michael Downey and it's fantastic to be back for another AWRI webinar. This is the first of 4 initial sessions that have been released for the 2019-20 program. So in coming weeks, we'll be addressing Weeds in the Vineyard, a new Wine Australia application for vineyard mapping and maceration techniques for developing wine style in reds. Today's session, however, has been planned to assist growers with preparing for the upcoming frost season. But before I jump over to today's guest speakers, some very quick reminders for you, the audience. To provide a comment or to ask a question, please open the Q&A section of the webinar, type in your question and click to send it through. If you'd like to get involved through Twitter, please use the Twitter handle @_AWRI. Now, the webinar is also being recorded and will be available to view later this afternoon from the AWRI's YouTube channel. All registrants will receive a link to this recording after the session. Now, for those of you that have just joined us, welcome. Today's session is a Bureau of Meteorology update, frost risk outlook and warning service. And I'm very pleased to welcome our speakers. So in the room with me today is Naomi Benger, a decision support meteorologist and the frost service lead in the Bureau's Agriculture Business Solutions Group. Also in the room is Darren Ray, a meteorologist and climatologist who works closely with agricultural sectors to inform decision-making based on available weather, climate and water data. So it's fantastic to have 2 experts from the Bureau joining today's webinar. And with that, I'm going to hand over to Darren to get us started.
Thanks, Michael. And it's great to have everyone who's tuned in out there. So what we're running through today, the aim of today is to really just highlight we're seeing climate influences around this season, which leading to an increased risk of frost. And so the aim today is to just highlight that increased risk, what that means for different regions. So there is differing risk depending on what location you're in. And also to highlight, we've actually just released some new seasonal outlook information, which will actually help people manage through the coming season in terms of managing medium timeframe information that will help people manage both the risk of cold extremes, but also hot extremes as well. So some new seasonal outlook material that I'll talk about through the presentation. So I'm just going to start by having a bit of a look at recent conditions, just to set the scene a little bit in terms of what we've been seeing in terms of rainfall and temperature, and what that means in terms of the background conditions leading into the growing season. Across Australia, where we've been seeing quite a dry year so far. So I've got January to July rainfall there on the left-hand side, rainfall deciles, just showing the very dry conditions. We've had a very dry August as well. So things have, for South Australia, we've had our second driest January to August period on record, looking across the whole state. And temperatures for daytime temperatures have generally been quite warm, quite a bit warmer than average. So those drier conditions, below average rainfall, have led to dry soils across many regions, and I'll show that shortly. Here's a map of our soil moisture levels from our water balance modelling system that you can go to and have a look at that on that web page. This updates every day on it's modelled water balance information. So it's got evapotranspiration, runoff, rainfall, soil moisture at 3 different layers through the soil profile that are modelled and updated on a 5-kilometre resolution across Australia on a daily basis. And you can go and drill down to a point level on that. So that's a tool that might be worth having a look at. But so I've got the difference from average here in the top 1 metre layer. And so you can see that's a lot of areas across Central Australia, New South Wales, a fair bit of South Australia, apart from the southeast, are seeing below average soil moisture levels going into the start of this growing season. Not so much the case in Victoria and the southeastern regions of South Australia, and a little bit of a mixed story across in Western Australia, depending on where you are. It's already been a pretty frosty year so far. So just got a map here from our gridded data set of June to early September frost nights across Australia. So you can see sort of parts up through sort of mid north of South Australia, Victoria, New South Wales. We've seen quite a number of frost nights already. So yeah, we have seen seen some above average numbers of frost nights already through this sort of winter and through to the start of spring so far. What's going on? So I'm going to have a bit of a look at the climate influences that are underlying what we're seeing through this year. And the major influence is the Indian Ocean dipole. So I'll just mention we were looking at the possibility of El Nino conditions developing in the Pacific Ocean earlier this year, but that's actually just that sort of the ocean patterns we're seeing across the Pacific that we're looking at a bit El Nino-ish have returned to neutral. If anything, they've gone a little bit slightly the other way away from El Nino. But the major influence that we're seeing is this pattern called the Indian Ocean dipole, and this is an influence in the northern Indian Ocean. You see variability from these different phases that can depart from the neutral situation. The negative phase, you see warm average water off to northwest Australia and cool and average near Africa. We get increased tropical convection, so the air rises up more easily and forms into rainfall, cloud and rainfall, and it feeds across the country, and we get wetter and cooler conditions through June to October into November. And that's what we saw through 2016. We had a really wet year, increased disease risk, but not so much a risk of frost this year. And we actually saw a bit of a moderate, sort of weak to moderate positive Indian Ocean dipole phase last year, where the ocean temperatures to northwest of Australia cooled off. The atmosphere tends to sink down more than usual in positive Indian Ocean dipole events. And so we get reduced cloud. And one of the impacts is we tend to see stronger high pressure systems over southern Australia. So we see impacts on the weather patterns as well as the moisture availability and the cloud. So if you think back to past years, 2015 was a positive one. It was, as I mentioned, it was a little bit weakly positive last year in 2018. Just to look at some of the impacts from the Indian Ocean dipole events in general. So I've got the rainfall on the top line for negative and positive Indian Ocean dipole events and the impact on temperatures generally. So this is maximum temperatures on the bottom there for negative and positive events. So negative events tend to be wetter, cooler daytime temperatures. Positive events tend to be drier, particularly over South Australia and Victoria and southern New South Wales, and warmer days. So I've got a diagram there of past events. So the blues are negative and pinks are positive events. So there's a few years in there that might sort of stick into people's memories. 92 was a particularly strong negative event, very wet. 94 was a very strong positive event. And you can get El Nino together with positive IOD events and La Nina events with negative IOD events. So 2015, for instance, was an El Nino event plus the positive Indian Ocean dipole. So anyway, I guess the key thing with frost events is the dry conditions. So you tend to get drier soil moisture or lower than average soil moisture levels because of the decreased rainfall in positive Indian Ocean dipole events. So where are we at the moment? This is a time series from our website. So we produce regular reports of the state of the El Nino, La Nina climate patterns, plus also the Indian Ocean dipole. And one of the things you can see on the website is this time series that's showing the values. So you can see the negative values in 2016, positive in 2015, sort of moderately positive, weekly positive through 2018. So the cutoff threshold tends to be plus 0.4 or minus 0.4 for the plus 0.4 for the positive IOD and negative 0.4 for the so negative IOD events. So if we crossed over that threshold back in during May, but it sort of did waffle around a little bit, but it's come back quite strongly through July. So we're now sitting well and truly, we're up around the plus 1 mark, so well and truly into positive Indian dipole territory at the moment. So one of the things we do, and you can see on our website on the climate, in the climate past weather section, is are these forecasts out of various modelling systems, both the bureaus and a bunch of international modelling systems of the positive Indian dipole. So we've got the bureaus at the top, Canadian, European, French, and then US and the UK Met Office, and the average of them are along the bottom there. So this is the forecast for September, showing that it's likely to strengthen even further into one further over above that 1 degree mark. So we'd like to see even further strengthening through September, and staying quite strong through October, and then starting to head back towards starting to weaken through November, which is very typical of the behaviour of the Indian Ocean dipole events. But we're still in that sort of positive ID territory even into November, and then really, as it's looking like it'll not really till December, it'll start heading back, getting towards neutral. So that's all pretty typical behaviour. Now the impact comes, so that combination of dry soils, but also the impact on weather patterns as well. So this is a forecast of September to November, difference from average of the surface sea level pressure. And we've got this pink above average, stronger than average surface pressure system. So indicating we're expecting to see stronger than average high pressure systems, as well as the drier soils, than the decreased rainfall. And that's all very typical. This pattern of changes in the weather patterns is very typical positive Indian Ocean dipole influence. So you can see this pattern in other parts of the world as well. New Zealand sees a bit of a different influence. So they tend to get more cold frontal systems because the high pressure systems parking over southern Australia. So the influence does impact other parts of the world as well, but in different ways, and to a fair degree opposite ways in some parts. So I'm going to drill down into a little bit more detail here. These plots are plots of the IOD value along the x-axis, or along the bottom here. So we've got negative IOD, neutral, and positive IOD territory. And then I've just shown the rainfall just for this one location, just to show you the influence on rainfall. So there is a correlation between the rainfall you get, negative correlation between the rainfall that's experienced across, particularly those locations across Central Australia and Victoria and southern New South Wales, and the rainfall that's experienced in IOD events. So you see generally that negative correlation. I've got the years of the occurrence on there as well. So 2006 was a El Nino and positive IOD event. As I mentioned, 2015. 2018 is in there. 1997 was an interesting one because it was a bit of an outlier event, but what we're seeing this year is looking quite different to what we saw in 1997. So that's just to highlight the impact on rainfall. So we're expecting rainfall to be something down in that sort of area for the next few months, and August has already been quite dry. So that's not great news in terms of water availability, but that's certainly the impacts we're seeing. This is an examination of the number of nights below that get to 2 degrees or less at Nuruyotpa, and from the station data. So you can see this positive correlation. So with increasing IOD values, you tend to get increasing numbers of frosty nights in Nuruyotpa. There is a fair bit of variation in there. So it's certainly not a one-to-one correlation, but there is a reasonable positive correlation that sort of leads us to increased risk of frost nights. So on average through August to December, you might experience on average about 10 nights, but it's looking like we might see maybe 50% more numbers of frosty nights coming through this through coming months out of through this season. I can't go everywhere with this, but I've ran a few other locations. So Coonawarra, once again, you do see a bit of a moderate positive correlation in there as well. So once again, it's something that you might expect on average, maybe 10 nights. So we're looking maybe something around 15 to 20. So something around a 50% or 50 to 100% increase in frost risk through this start of this season, through coming months. I've gone to Stawell in Victoria, so trying to get somewhere close to Great Western in Seppelts, maybe in there, and that positive correlation still holds a little bit. It's not as strong, but there's a tendency to a little bit of increased frost risk there. So averaging 10 nights, but perhaps something more like 15 to 20 they might expect through the next few months. Renmark in the Riverland, so once again a positive correlation in there. So they might expect normally maybe 12, 13, 14 nights, and that might sort of push it up a little bit to maybe 18 or so over the next few months. Cessnock in the Hunter is still a little bit of a positive correlation, but it's not as strong in there. But a little bit of an increased frost risk in there as well. And where it does break down, and this is not a surprise because of the impact of the positive IOD across Central Australia and the sort of southeast of Australia. The breakdown for southwest WA, so looking at Witchcliff, there's not really any sort of particularly positive or negative correlation in there showing up. So they're not seeing any sort of shift either way. So I'm going to sort of break down into the medium time frame. So looking at the sort of 4-week time frame through the seasonal outlook. I'll start with the seasonal outlook. So this is updated last week. This is from our Climate Past Weather page, and you go into outlooks. And so looking generally for rainfall, so we're seeing that dry signal from the positive IOD is quite clear through September, October, November. So that's sort of very low likelihood of exceeding median rainfall across that whole period. That's certainly the case in September, not so much in southwestern WA and in Tasmania and in perhaps southern Victoria as well, but it certainly strengthens in October. And so we get quite a broad dry signal in October across all of mainland Australia, but not so much the case for Tasmania. So more of a 50-50 signal for rainfall in Tasmania. Maximum temperatures, it's just a pretty broad-brushed indication that it's really likely across almost everywhere, apart from, once again, Tasmania, perhaps parts of southern Victoria to be warmer than average maximum temperatures. And for minimum temperatures, so we're seeing for overall this sort of 50-50 signal. So we've got and this is where it gets a little bit tricky, because we're seeing some indications of some warmer nights mixed up with some frostier nights in there, so leading to a somewhat 50-50 signal. So we've got a mix of patterns that are combining in here. That some of the weather patterns can lead to some warm. So I guess quite variable nighttime temperatures is probably one of the message to take away from here. But it does show a bit of a mixed story in September, but does strengthen things in October. And that's one of the things we're seeing in the outlook, is that the frost risk is probably not so bad through the remainder of September, but we're seeing a pretty clear signal of some quite strongly increased frost risk in October this year. Now, one of the things we can do is drill down a little bit, and I'll just go into this. Oh, sorry, what's going on there, Michael? I just wanted to go out to the web. Can we do that from here? Is that?
Yep.
Yep. Okay. Sorry.
No, you're right.
So I should have flagged this before we started that I was hoping to do this.
Okay.
Okay, so what I was just hoping to do was just to show people how to get onto this new seasonal outlook information that we're showing. So just go to the Bureau's homepage and into the climate past weather page. And we've got our outlooks on the top left. And so there's the El Nino La Nina IOD summary report. This video here is well worth a look. You can subscribe by email to the Outlook, so you can pop your email in there. So I'll just leap into this one. So one of the things we've done is in this latest release, which happened last week, is we're actually providing weekly and fortnightly breakdowns. So prior to this, we had sort of 1 month ahead, 2 months ahead, and then 3 month block. Now we've got here is the ability to go in and look at the temperature or rainfall in a little bit more detail. So I'm going to go into difference from average and for minimum temperatures. So let's go into minimums, difference from average, and I might get rid of the locations. Now, one thing I'll point out is this information, we've actually made it available on a global level as well. So the basic point is you can actually flick through different periods ahead and look at the temperature anomalies across Australia, so you can get a sense of what period is likely to be hotter or cooler through that coming period. So I'll go back to the charts above median, and then you can extend it out to that sort of month ahead time frame. So you can see that clear signal there for cold nights across those regions. So we've got Tasmania in there, Victoria, southern New South Wales. Not so much the Hunter is looking warmer, and Western Australia's got a little bit of a 50-50, not 50-50, if not likely to be warmer signal in there. So that's you can do the same thing with temperatures. It is also available globally, so you can actually zoom out and get click on there and get a global view. Once again, so for people in other regions that are hooked in, this, there is some actually potentially useful information there that they might find interesting to have a look at. Anyway, I'll leap back to the presentation. So, is that showing up? No, need to. Great, thanks, Michael. So that's basically just highlighting, go and have a look at those summaries. Pop your email in there, subscribe, so you can get the link come through when they update twice a month. And the models do get updated at, I think, at least once a week, but within latest model runs. So these maps will update quite frequently. And one of the things we're doing experimentally is running these various sort of 30-day time frame information for our Access S seasonal outlook model. And so I'm just going to run through this quickly for just a couple of locations, just to show people some of the capability in there that we're exploring at the moment. So we've got a time series here of minimum temperatures for Coonawarra. That's showing sort of frosty nights at the moment. Warms up a bit through the middle of September. And then we get some likelihood of some frosty, a little bit frosty through second half of the month, so around about the 17th and 18th, and warms up again a little bit, and then we get a little bit of sort of some risk of frost in around about the 23rd, 24th. But overall, if you look at these sort of, break it down by these sort of weekly and fortnightly periods, frost risk is not particularly severe through September. But we are seeing this likelihood of October nights being a little bit frostier. So this sort of information as we go through into October might actually be of a little bit of interest. I've got Great Western in there. Similar sort of story that when actually the frost risk of September is not looking so bad. But October is showing up to be that sort of period of increased risk. So that's better. I think just a quick summary, we've got drier than warmer than average conditions, and it's particularly across Riverland, so Central Australia, New South Wales, and it does extend over that 6 month to 3 year time frame. July to August rainfall patterns have been very typical of that positive indiation dipole climate influence. We're seeing low soil moisture levels for many regions, not everywhere, but it's not so much the case of Victoria and southeastern South Australia, but certainly everywhere else is tending to be a bit dry for the soil moisture levels. The positive indication dipole is really the main influence, and that's looking like it'll be around certainly through September, October, November, before heading back to neutral. We are seeing so these sorts of conditions that tend to increase frost risk. You tend to also see an early start to the fire season, drier than average conditions, further inflows to water catchments. So it's certainly going to increase not help water availability, and I'm hearing that's people are not people's water levels in dams are certainly decreasing, and water availability is certainly an issue, and that we're not seeing anything that's going to help that. So we'll be back in, I think, late November to talk about the outlook as we go through the remainder of the growing season into harvest. And but it's just worth highlighting that we certainly, the impact of the positive indication dipole is very likely to not help water availability over the next few months. And as I mentioned, in looking at some of those locations in a bit more detail, the risk of frost is tending to be about 50% higher to some locations, maybe 100% higher. So certainly an increased frost risk, and October looks to be a really high risk period. And that we do have that new weekly, fortnightly outlook information that can help manage both frost risk, but also as we go through into the hotter time of year. It'll actually be, I think, potentially really useful to pick the heat as it comes through as we go through summer into towards harvest. So that's it from me, and I'll hand over to Naomi.
Okay, thanks, Darren. While I'm pulling up Naomi's presentation, if you do have any questions, please start sending them through. We will run a dedicated Q&A at the end, but if you've got any questions now, start typing them in. And it's over to you, Naomi.
Thank you. Good morning, everyone. My name's Naomi Banja, and I'm part of the agriculture program. I work as a decision support meteorologist, and I'm the frost service lead. So I spend a lot of time helping people make decisions on how to mitigate frost. So today I'm going to break it down for you. I'm sure you're all very familiar with the situations which lead to frost over your properties and regions, but I'm just going to break it down into detail so that I can help you use the data that's available to you to forecast for your region as well. And using free information online, there's available information on our website as well through METI. And then I'll talk just a little bit about the specialist location frost service that the Bureau is piloting at the moment. Okay, there's a few different types of frost. In Australia, we generally mainly experience radiation frost. It's the most common. It occurs as the ground cools overnight. A lot of heat is lost from the surface, so it begins at ground level and gradually rises through the atmosphere to higher objects, so into the canopies and into the fruit. Advection frost is rare but can occur when a very cold air mass moves in behind a cold front, for example, with other clear and cool conditions behind it. That can occur at day or night, but it is quite rare. So I'll talk mainly about radiation frost. There are three main elements for radiation frost to form. We need clear skies. Clouds actually sort of act like a blanket, like the little pug here, to prevent heat from escaping from the Earth's surface. So that's why tree wraps and covers can prevent frost damage. Humidity can also prevent frost formation because as the moisture in the air converts to ice, it releases latent heat. So it's a little bit counterintuitive, but it actually means that frost is less likely to form. So this is why spraying can also prevent frost, but of course, need to be very careful with that frost mitigation process. We don't want ice to be forming on the surfaces instead of frost. Wind also prevents frost formation. So wind can mix the warmer air aloft with the cooler air closer to the surface, and that slows the cooling of the air mass generally. So that's why fans and helicopters are often used to mitigate frost. It's important to make sure that the air aloft is actually warmer, that it is a radiation frost, and a lot of frost fans have thermometers at different levels, so they check that before they turn on. So it's pretty simple to break it down into a little recipe, really. We need cold and dry air, we need clear sky and low winds. So just looking at Tasmania in these synoptic images, these are the ideal conditions for frost to form over Tasmania. But like any recipe, it's not foolproof. There are a lot of things that go into frost. Those three elements are the necessary conditions, but they are not sufficient conditions. Frost is a very localized phenomenon. So we have topography and location, land use. There are so many other elements that can influence whether frost forms or not. So when you're looking at forecasting frost for your particular properties, you can access a lot of data freely available online from our website and from a lot of other sources. Just a couple of things to note about the data that you have available to you. The data available through the Bureau has 6 by 6 kilometre resolution. It's also given a once over by meteorologists. They spend a lot of time refining the model data that comes in to make sure that the weather conditions are captured on the very fine scale that the models simply don't have the capacity to do. Other models that are available online and packaged very in a very aesthetically pleasing way sometimes don't have the same resolution. Sometimes they can be as coarse as 40 kilometres. And you can imagine there's a lot of change in land use over 40 kilometres. So it's very important to firstly know where your data is coming from. If you get 3 or 4 different sources online, you may actually be looking at the same data packaged in a different way. So you may feel like you're making a good forecast because you've got 3 different sources which seem to agree, but in fact it's the exact same information presented a different way. So firstly, make sure you know where your data is coming from, and also make sure you're using it in the correct way. So when we produce our forecasts at the Bureau, we are forecasting for our specific observation sites, and that's for quality control, for verification, but that's not necessarily the best forecast for your vines. So temperature, we're forecasting for a Stevens screen, which is a sheltered thermometer setup, which is 1.2 metres above the ground. That means that the surface can actually be around 2.2 degrees lower than the forecast temperature. So you can see frost formation on the ground when the frost is not actually affecting the canopy. Wind is forecast for open terrain at 10 metres above ground level with no obstructions. And we know that that's not exactly indicative of what you'll experience in your vineyards. Humidity, of course, we're forecasting the atmospheric humidity, but of course, if you've irrigated, it'll be quite different to what's out in our forecast product or in any forecast product. And then, of course, we get into the fine scale, which is how is the land used, and do you have a sloping block? Is there a dam? Do you drip irrigate? Do you spray irrigate? Do you have nets over your vines? All of these can affect whether frost forms. So make sure you take these into account when you use the data. Okay, so you can access the data for free on our website. There's some maps that also give you a big picture idea of whether your area is prone to frost. Darren showed you some great outlooks. We've got some maps that also show on average, the number of days where the minimum temperature is less than 2 degrees. So remember, because the surface can be about 2.2 degrees lower than our forecast temperature, frost can form on grassy surfaces at 2 degrees forecast and 2 degrees observed. And then, of course, I know some of you will be very surprised to hear that our forecasts aren't actually perfect. We do a pretty good job of predicting the future, but there's a lot of uncertainty in forecast data, and that's something else that needs to be taken into account when you're managing frost risk. So just a quick example here of how we try and capture the uncertainty in our public weather products. You can see the rainfall forecast here is broken down into 3 elements. We have a 70% chance of a measurable amount of rainfall, that's 0.2 millimetres. A 50% chance of getting at least 1 millimetre, and a 25% chance of getting at least 5 millimetres. So we try and capture it in rainfall, but you can see the minimum and maximum temperatures are simply 8 and 16. There's not really any indication of the uncertainty which surrounds the temperature, but of course that exists as well. So in our particular location-based service, we give a visual product. We send out a visual product that goes for 7 days, twice weekly. I've just shown the 3-day version here for simplicity. It shows the temperature. You can't actually see the uncertainty bars around this temperature example, but they generally have some bars of uncertainty around them. I've got a box which highlights an area or a time period where frost risk is high. You can see the temperature dips to below 0 at this time, and it gets to, at 2 degrees at this time, so the risk of frost forming on the grass exists. And then at around a couple of hours later, you can see that the frost risk reaches the canopy height. You can see that the winds, this is wind strength in the blue bars, the winds are light, they're quite variable, also indicative of frost risk. Some areas will have favourable directions for frost, and so in some locations, for example, a northerly will mean they'll have no frost, but a southerly means they'll have a severe frost. This bar here shows rainfall. There's no rainfall, another indicator that we've got a relatively dry air mass, so low humidity, and cloud cover. So there's a little bit of an indication of low-level cloud. It's not particularly deep, so we wouldn't expect this cloud to be overcast. It would probably just be some partly cloudy areas overhead. So there is a high risk of frost on this particular night here. So this is the kind of service that we can supply, and we don't just send this out and leave it up to you to fend for yourselves. That's where the decision support meteorologist comes in and helps you to interpret these graphs for your particular location. So basically our point-based frost service has 2 elements. We want to help producers develop the skills to learn about forecasting frost, and then we want to supply them with the data that they need and the analysis and support that they need to be able to forecast frost well in advance. Okay, so if you'd like to learn a little bit more about that or anything else, feel free to contact me directly at my email address or at the agriculture@bom.gov.au for general agriculture questions. But I'll hand back to Michael now. Thank you.
Okay, great. Thanks very much, Naomi. From here, we're going to roll straight to a Q&A. So if you do have any questions, both Naomi and Darren are going to stick around for a little while to address any of those queries. Just a reminder, if you do want to ask a question, open the Q&A button on your webinar toolbar and click to send it through. I've already got one question that's come through. So a question here from Chris, who read recently that there was a stratospheric event occurring near the South Pole, which occurred in September 2002 and 2010, but which only really affects New Zealand weather. Is this true? Can it affect Southern Australia weather? And if so, how?
Yeah, no, I can go in on. So yeah, we're just starting to see the start of what's called a stratospheric sudden warming event. So we can see so when we're talking stratosphere, we're talking the layer of the atmosphere up sort of 10, 20, 30 kilometres in the atmosphere, and they're fairly rare. Basically, you see a fairly quick warming over a few weeks of that layer by a fairly significant amount, and they happen a lot more frequently in the northern hemisphere. So they're a bit rarer in the southern hemisphere. And as you mentioned, there was one in 2000, quite a strong one in 2002. This looks like it's probably going to be the strongest one in the southern hemisphere since 2002. And so basically the temperature in the stratosphere impacts weather patterns at the surface. And so it actually, what happens in these sorts of events is you actually see what's a more, you basically see a relaxation of the weather patterns so that so you actually get it actually allows for more of a tropical, less of a tropical influence, and allows the cold fronts to come further north than usual in these sorts of southern stratospheric warming events. So it impacts the surface weather patterns, and it can go for a couple of months. So we're just seeing it starting now, and so the impacts we're likely to see, the impacts vary considerably on the time of year that it occurs. So having the cold fronts come further north and less of a tropical influence would be great if this was happening maybe a couple of months ago. So it would actually lead to more cold frontal activity and rainfall over southern Australia, and would have opposed the positive IOD influence to some degree. So that would have been fantastic. The fact it's happening now, and we're going to see it through spring, means that it's actually going to reinforce the positive Indian Ocean dipole influence over southern Australia. So it's actually not great news, because it's actually going to reinforce the drier and conditions and that we're seeing at the moment. So for southern Australia, basically the influence is going to reinforce the dry conditions we're seeing at the moment. The influence on New Zealand is quite different. So people think back to that weather chart I showed with the high pressure systems over southern Australia and the probably more cold frontal systems over New Zealand. That'll probably actually reinforce that pattern a bit. So we'll actually see the opposite impact on New Zealand compared to southern Australia. So anyway, sorry, a long-winded answer, but yeah, the short answer is it's actually going to reinforce the positive Indian Ocean dipole influence, unfortunately.
Okay, great. Thanks very much for providing such a comprehensive response there, Darren. Thanks for your question, Chris. We've got another question here from Liz around the frost forecasting service and whether it's based on latitude and longitude, or is it based on towns, and also whether there are any costs involved.
Okay, yeah, thanks for the question. So the forecast is that it can be based on a lat long, and it is based actually on our ADFD grids. So it's the forecaster derived forecast parameters. It's got the 6x6 kilometre resolution as well. There's a slight cost involved. It's not a money-making project. It's really just cost recovery. So it depends on the extent of the service. So if you're interested in receiving these, you can send me an email to get a little bit more information. Those particular time series are not available on the website because they are site specific, and they are sort of more of a briefing tool with the advice from a decision support meteorologist rather than something that we just leave you on your own to use. Sort of answers the second.
Great, thanks for that, Naomi, and thank you for your question, Liz. Another question here from Matthew. Are the frost forecasts based on METI predictions? And how do you assess on the BOM website the frost charts portrayed in the presentation?
Yes, they are the ADFD data. So it's not just model data, it's based on forecasters intervening and adding extra detail. Those particular time series aren't available. It's a bit of a trial product. That's why it's just there's a small sort of cost recovery cost associated with it. The other information you can access freely. So everything that's available on METI gives you all the information you need. It's just not displayed in a sort of frost forecast specific format as those time series are that I showed.
Okay, fantastic. Thank you, Naomi. We'll wait a little bit longer to see if any final questions come through, but that seems like it might be it for the time being. Just a reminder to the audience, if you do want some additional information around mitigation and what to do post frost events, the AWRI did record a webinar back in 2017 with Sonia Needs. This is available via the AWRI's YouTube channel. So we have had another question come in from Hans. Aside from the IOD influence, does the temperature of the Southern Ocean influence the number of frosts?
Yeah, great question, Hans. Temperature of the Southern Ocean. So, I mean, this is sort of back to Naomi touched on, the role of humidity. So, if you are in a more coastal location, the moisture coming off the oceans will certainly have an impact on frost occurrence. And so, how warm those oceans are will certainly have an influence. Now, we're not seeing, we are seeing a bit of some mixed, I guess, a bit of a mixed story about temperatures around southern Australia in terms of those who are located in coastal areas. So the temperatures around Tasmania have been quite warm and quite a bit warmer than average, and around southern Victoria. And that's, if you think back to those minimum temperature outlooks, that's probably where some of that sort of probably is influencing some of the is reflecting in some of those outlooks, that we are seeing warm average temperatures around the Victorian coastline and Tasmania. Not so much the case elsewhere in the country, where things are a little bit more average. It's probably a little bit warmer than average along the eastern coast at the moment. But yeah, that warming that we've seen around Tasmania and central Western Victoria has been quite marked, and that is likely to have an influence on coastal locations.
Okay, thanks again, Darren, and thanks, Hans, for your question. I think that'll be it for the Q&A, so we might start to wrap it up if Naomi and Darren are happy to leave it there.
Yeah, I'll probably just reiterate Naomi's point.
Just a second, Darren.
Sorry. Yeah, I'll just reiterate Naomi mentioned, if you do want to get in touch, we've got our agriculture email, so agriculture@bom.gov.au. If you do want to get in touch or follow up, feel free to use that.
Yeah, that's a great reminder, and I'll make sure that contact details are sent out in the post-session notifications. So everyone in the audience will have those details. So like I said, I think we'll finish there. I'd like to first extend a large thank you to Darren and Naomi for coming in and presenting. Thanks, guys. And I'd also like to thank you, the audience, for participating and joining in today's session. Attendees will receive a follow-up email with a link to the recording. I'd also like to remind you about the next AWRI webinar, which is on Thursday, the 19th of September. Tony Hoare from the AWRI will be discussing weeds in the vineyard. If you haven't registered for this session and you would like to do so, please visit the AWRI website. That's all. Thank you again, and I look forward to seeing you at the next AWRI webinar.